Hi, welcome to our channel and back to the tutorial for machine learning. Today we're going to see the topic called regression in machine learning, that is linear regression machine learning. So in the previous session I explained about what is class based regression. Just I want to convey some points here. So here regression means what? Here now what is regression? You can say it's a technique for investigating the relationship between independent variable or features and a dependent variable or outcomes, remember, and where we can say it is used as a method for predictive modeling in machine learning, in which an algorithm is used to predict the continuous outcomes here. Apart from this, here so regression concept two types. One is called simple and multiple. Under simple you have linear regression and non-linear, and under multiple regression also we have concept of simple and linear and non-linear. We are going to see the generally about linear regression. Let's go for the session today. So simple and easy. So linear regression, what you can say is a one where involves using data to calculate line that the best fit the data. Remember, and also using that line to predict scores on one variable from another. Prediction. So here the term we are going to see new is called prediction. That means what? It's simply a process of estimating scores of the outcome or variable based on scores of a predictor or variable, you can say. Moreover, to generate the regression line, we look for a line of best fit. So whenever for intro machine learning about asking means you have expert this kind of question only, the line which can explain the relationship between independent and dependent variable, and also it's said to be better the fit line. Moreover, the difference between observed value and actual value is given here, that is y is equal to m0 plus m1x1 plus m2x2 plus m3x3 and so on and so on, m1xn, where what is the meaning of y here is dependent variable. So here to remember the difference in the pointers. So here y, capital Y represent the dependent variable and x are the independent variable, remember. And the right hand of the equation is also known as the hypothesis function, that is h of x. Line of best fit. So just now I told you line of best fit, this was fitting. Here the purpose of line of best fit is what? That the predicted values should be as close as possible to the actual or observed value. And also this means what? The main objective is what? Determining the line of best fit to minimize the difference predicted values and observed values here. So here there are this the diagram representation showing here. So 0, 2, 4, x is the this 0, 5, 10, like that is a graph is there. Here there are three ways to calculate the error, that is called sum of errors and sum of absolute value and sum of square. Then we have formula like this, and a line of best fit for one feature can be represented as y is equal to capital Y is equal to bx plus c. Here where y is the score or outcome variable we are trying to predict, and b is equal to regression coefficient or slope, and c is equal to y intercept or the regression constant. This is the one. Here sum of squared errors. Here squaring the difference between actual value and predicted value is for the more each error. Moreover, like the result here, the line, this methods here somewhat you can say method of least square here. And baseline model. Here, what is baseline model is nothing but it refers to the line which predicts each value as the average of the data points. And sum of squared error. It is a total of all squares of the errors. And also it is a measure of the quality of regression line. Just now I told you what is regression and so on. Moreover, SST is total sum of square, that is SST for baseline model. Here regression metrics. There are regression metrics consist of mean absolute error, then mean square error, squared error, and R squared. Here this is one way to measure the error is by using absolute error to find the predicted distance from the true value. So these kind of things when you easy to understand when you go implementation of some applications. So here now what is what? Linear regression. There are now some regression metrics. Here squared error, this is the one most common metric to measure model performance here. And here then R squared is it is called coefficient of determination, where it is a formula that is R minus square is equal to 1 minus sigma y actual minus y predicted mod 2 and y sigma of y actual minus y mod, so y mean and mod 2 here, like that. So whenever free time you can check everything. So we give the quick constant, then cost function. The error of regression model is expressed as a cost function. That is the formula consists of here g of theta 0 comma theta 1 and 1 by 2m sigma I is equal to 1 to m value, then limit, then h0 of x of I and y of I square like that. Then come to inside cost function. We have one formula is let's have a graph given here. So like that, this is a graph. Whenever you go free time, you can check it out everything, and the comment box you can comment any not getting like that, anything not getting. So again, some calculation going, then gradient descent. This is one of the term, and expert for the interviews also machine learning regarding. So the process of minimizing the cost function can be achieved by gradient descent algorithm. So if you want to minimize the cost function, what you can do? You can implement the gradient descent. This is one of the algorithm. How it means there will be a diagram given here, and start with the initial guess of coefficients, then keep changing the coefficients a little bit to try and reduce cost function, that is g of theta 0 comma theta 1, and each time the parameter are changed, gradient chosen which reduce g of theta 0 comma theta 1 the most, and repeat and keep doing all till no improvement is made. If an improvement come, the algorithm becomes success and you can stop the procedure. Otherwise, you can repeat the steps from step number 1 to 4. So simple and easy gradient descent. Then polynomial regression. Instead of finding the best line, so one more option is that is instead of using the best line data and the given data, we can try to find the best fit curve. So when you got polynomial regression, we can remember the curve only, curve of the graph. The graph can show the curve, and this is a form of polynomial regression where the formula that means y is equal to theta 0 plus theta 1 x and plus theta 2 x square, that is quadratic regression. And also third order formula is y is equal to theta 0 plus theta 1 x plus theta 2 x square plus theta 3 x cube, that is cube regression. So like that will be there. So instead of best of it, what is alter? You can say polynomial regression here. Then come to the overfitting and underfitting. So here it's a question as here. So what you can do means, so what should we always choose a complex model with higher order polynomial to fit the data set? The question asks like that. No, we can say no. Some wrong prediction there, so we can use you can have underfitting here. The concept of underfitting, it occurs when our model neither fits the training data nor generalize on the new data. Remember. So here the underfitting, just right. Overfitting is there. These also will get clarity whenever for application. When you implement the experimenter application, when you apply this concept, you can avoid it. You can now you can detail that bias is there. So what is bias? It's also can spot machine learning into questions. Bias occurs when a model has enough data but is not complex, but enough to capture the underlying relationship or patterns. So here what you can say means some data is there. You can it's not be more tough or complex, and also capture the underlying relation. Whenever capture data, we can find the relationship. For example, if we get the cricket score, what will happen? We can take about overs, balls, runs, and so on and so on. Then variance that when we are training model, we typically use a limited number of test samples from a larger population. Remember, if you repeatedly train a model, what happened with randomly selected subset of data, we would expect its predictions to be different based on the specific example given to it. So like this, so many things is there. And adjust R square. This is one. The R square always increase or remain constant. Remember. So here we have one formula. If you go for this one deeply, the formula what is a R square adjusted is equal to 1 minus R square in multiplies n minus 1 by n minus p minus 1, small letter 1, where R square represents a sample R square and p number of predictions and n square total samples. So when you go for our linear regression deeply, we need this all. We need and consider these all things here. So these are about something about the linear regression. If you have any queries or suggestions, please kindly communicate with the social media. Thank you for watching the video. Thank you. And share. If you like the video, please share and subscribe.